Okay, so we're already in chapter 11 of the systems analysis and design, and this is all about managing systems implementation. So, what is this all about? So, let's start our lesson. So, for the phase description, systems implementation is the fourth of five phases in the systems development life cycle. It includes application development, documentation, testing, training, data conversion, and system changeover. The deliverable for this phase is a completely functioning information system. And for the chapter objectives, we have explain the importance of software quality assurance and software engineering. Describe the application development process for structured, object-oriented, and agile methods. And draw a structure chart showing top-down design, modular design, cohesion, and coupling. Explain the coding process, explain unit, integration, and system testing, differentiate between program, system operations, and user documentation, list the main steps in system installation and evaluation. Then next is develop training plans for various user groups, compare in-house and outside training, and describe effective training techniques. Describe data conversion and changeover methods, and explain post-implementation evaluation and the final report to management. So for the introduction of this chapter, the system design specification serves as a blueprint for constructing the new system. So system design specification is from the previous phase. And then the initial task is application development. So before a changeover can occur, the system must be tested and documented carefully, users must be trained, and existing data must be converted. And then after that, a formal evaluation of the results take place as part of a final report to management if the new system is effective or helpful to the business processes. So first is we going to have to tackle about the software quality assurance. So software quality assurance for software engineering, we have this capability maturity model or CMM. So CMM, it is a development model created in 1986 after a study of data collected from organization that contracted with the US Department of Defense who funded the research. And because of this development model, we have the Capability Maturity Model Integration or CMMI. So CMMI is a process and behavioral model that helps organizations streamline process improvement and encourage productive, efficient behaviors that decrease risk in software, product, and service development. So CMMI is all about process improvement. So this tracks an organization's processes using five maturity layers. So these are the five maturity layers. We have the initial, manage, defined, quantitatively manage, and optimizing. So let's just have by this in the image for the initial, the process is unpredictable, poorly controlled, and reactive. And then if it is mature level number 2 for managed, process characterized for projects and is often reactive. And then we have the maturity level number 3, we have defined process characterized for the organization and is proactive. And then we have quantitatively managed, process is measured and controlled, and of course, the highest maturity level for CMMI is the optimizing. So focus on continuous process improvement. So it is mentioned here, we have the term reactive and proactive. So um, how are we going to relate the words reactive and proactive? In our real world situation, for example, in ourselves, for example, if your instructor gives you difficult projects and and your reaction is, oh, the teacher is like a monster. He's always giving us difficult projects that it's almost undoable. So that reaction is reactive. Why? Because you're not seeing a bigger picture. That's the reactive. While if you're going to be proactive or your positive reaction to a situation. For example, again, your instructor gives you difficult projects. If you are a proactive person, then you will be reacting as, oh, maybe it's not really personal for her. It's just that our instructor just wants us to learn for example, the difficult thing, so that we will know, and not because he or she is angry with us. So that is the difference between reactive and proactive. So with regards to process, it's also like that. It's not just because for processes, you're just going to make the process just to comply, but as much as possible, the processes must be proactive. It will help. It will really help the organization. Okay, next is we have another one. We have the International Organization for Standardization, or ISO. So many firms seek assurance that software systems will meet rigid quality standards. Actually, ISO has many certification. Our university, Batangas State University, has acquired the ISO 9001:2015 certification. It is all about quality management system. So, what are the metrics, or what is the objective of the quality management system? So, it needs to demonstrate its ability to consistently provide products and services that meet customer and applicable statutory and regulatory requirements. And another one is we have to aims to enhance customer satisfaction through the effective application of the system, including processes for improvement of the system and the assurance of conformity to customer and applicable statutory and regulatory requirements. So that is the ISO 9001:2015 certification, all about quality management system. There is also an ISO certification for software engineering, which is the ISO 90003:2004. So it is all about software engineering. So provide guidance for organization in the application of ISO 9001:2000 to the acquisition, supply, development, operation, and maintenance of computer software and related support services. So always, as always, ISO requires a specific development plan. Okay, so much for software quality assurance. Next is we have the overview of application development. So the objective of application development is to translate the design into program and code modules that will function properly. So we're going to create already code, or we're going to create the information system. And then you have to review the system design, tasks, produce an overall design, and a plan for physical implementation. So what are the application development tasks? We can choose it's either the traditional method or the agile methods. So for traditional methods, start by reviewing documentation from prior SDLC phases and creating a set of program design. And then at this point, coding and testing tasks begin. And then next is we have the agile methods. Intense communication and collaboration will now begin between the IT team and the users or customers. And the objective of this method is to create the system through an iterative process. So from these two methods, agile methods is newer than compared to traditional methods. So what are the system development tools that you can use in the application development? Okay, you have to review your entity relationship diagrams, the flowcharts, the pseudocode, the decision tables, and decision trees. And then also, we're going to be needed the project management. Even a modest-sized project might have hundreds or even thousands of modules. So it is really a must to have a project management skill. So important to set realistic schedules, meet project deadlines, control costs, and maintain quality, because that is the purpose of having a project management. And then should use project management tools and techniques. So first is we have the structured application development. So for structured application development, we're going to use structured charts. So structured charts is composed of a control module, a subordinate modules, the module itself, the data couple, control couple, condition, and the loop. So we have these are the modules, and then this is the control module, the module 1, and then it can be broken down into many or more module, which is called the subordinate modules. And then we also have this data couple. So data couple is the symbol is arrow with an empty circle. And then the control couple is arrow with filled circle, shows a message or status flag. And then of course is a condition if it is a yes or a no. And then we also have the loop. Okay, so we have an example here of a structure chart, of a simple structure chart for update customer balance. We have these two. We have the tightly coupled and loosely coupled. So we also have the term for cohesion and coupling. So if you need to make a module more cohesive, you can split into separate units, each with a single function. So we have an example here. So update customer balance, and then the process, the subordinate module is calculate current charges. So with calculate current charges, the data coming from calculate current charges is the new balance that is already computed. And then it needs before the result of the new balance, customer number, new changes, and old balance must be coming from the module update customer balance, the data. And then we have this control couple, which is the symbol arrow with a field circle, apply discount flag, a message or a flag. And then when this three data and then the flag is accepted by the calculate current charges, then it will produce a new data couple, which is new balance, and it will be directed back to update customer balance. So this is tightly coupled. Why? Because in one of the module, you can the apply discount and calculate current charges are in the same module. So that is tightly coupled. Then for loosely coupled, we have what have you noticed that the module is it's still broken down into two more modules. So for example, to calculate current charge, so we need customer number and the old balance and the new changes, and then the new balance will be sent to update customer balance module. While for applied discount, what data do you need from the update customer balance is we have the customer number and balance before discount, and then the module will be implemented or executed, and then a new data balance after discount will be directed back to update customer balance. So it is loosely coupled. So it cohesion is related to loosely and tightly coupled. If you want your module to be more cohesive, you can split it into separate units, each with its function. So this is loosely coupled. At the same time, it is more cohesive because you have separated the modules with a single function. So while this is a tightly coupled and it is less cohesive because the operations for applying discount and calculate current charges are in the same module. Okay. And then we have loosely coupled. So I've already discussed about the loosely coupled and the tightly coupled. So another definition for it is for the loosely coupled. These are independent. You have to create independent module, which is desirable because it will, for example, if your modules are loosely coupled, it is not dependent on the other module. If there is an error, it will not be directly affected. If there is an error with that module, it is not directly affected the other module. So that's why it is loosely coupled. So it is more desirable than tightly coupled, which is one module is linked to internal logic contained in another module. The problem with tightly coupled, if there is a problem with the module and it is linked to that module, the module in question will also encounter problems or issues. So that's why it is considered the most desirable characteristic is that modules must be loosely coupled and more cohesive. Okay, so how are we going to draw a structure chart? We have step one. We have to review data flow diagrams. So review all DFDs for accuracy and completeness. And then step number 2, identify modules and relationships. Transform functional primitives or object methods into program modules. And then 3-level structure charts relate to the 3 DFD levels. And then step number 3 is add couples, loops, and conditions. So identify the data elements that pass from one module to another. So you have to really think what is the data needed for this module, and at the same time, if the module is finished executing, what data will it produce, and it will be returned to the module. And then step 4, analyze the structure chart and the data dictionary. Ensure that the chart reflects all previous documentation and that the logic is correct. Okay, so we have the structured application development by using structured charts. So we have another one, the object-oriented application development, or the OOD. So the characteristics of object-oriented application development, the application's structure is represented by the object model itself. As you can remember, we have this object relationship diagram. So implementation of object-oriented designs. The main objective is to translate object methods into program code modules and determine what event or message will trigger the execution of its module. And then for in relation to object-oriented cohesion and coupling, the classes are loosely coupled and the methods are also loosely coupled and highly cohesive. So we have these traditional methods, and next is we have the Agile application development. It is a distinctly different systems development method. The development team is in constant communication with the customer, focuses on small teams, intense in communication, and rapid development iteration. And one example of Agile application development is the extreme programming, or for short XP, is one of the newest Agile methods. So, extreme programming aims to produce higher quality software and higher quality life for the development team. So, these are examples of extreme programming. So, user story is you're getting an input from the user. For example, the user wants this process to be improved. So, that is already an example of a user story. And then, we have the release plan. So, since this is the what the user wants, so you will have a plan for the release of each user stories. And then we have the iteration cycle, which is commonly 2 weeks long. So that is the time that you're going to do the user stories. And then after before every iteration cycle, we have the iteration planning meeting, in which the user story can be broken down into tasks so that the team will work on this task. And then parallel programming, this is where, that's why the word parallel. So two programmers are going to encode or going to create the task or the program for the said user story. And test driven design, because this is an iterative process. For every design, for every program that you're going to produce, you have the team must also test it, so that it will it of course, that's why you're testing it, so that you have to make sure that it is working. Okay, what is the future of agile development? So critics claim it lacks discipline and produces systems of questionable quality. So that is the problem with the agile development. So before implementing agile development, the proposed system and development method should be examined carefully, because agile development has this one size fits all solution, but it is not applicable all the time or in a particular context or situation. Okay, next is we have coding. Of course, if you're going to code, you're going to already translate the systems design into a code or program that will be used by the organization. Okay, for coding, of course, you will need programming environments, or the IDE, or the integrated development environment. And then we also have this tools that can generate codes. So the generating code can generate editable program code directly from macros, keystrokes, or mouse action. So it depends upon, so it is easier for it if there is a generating code. Okay, next after coding is you have to test the system. So we have three types of testing. We have unit testing, integration testing, and system testing. So we have an illustration here. So for every program, so we have 6 programs, and then you're going to test it individually without individually isolated. So these are called unit tests. But for example, this program 4, program 5, and program 2 will be tested together. So that is, and of course, it does not necessarily mean that they are working separately, that if they are working separately, that if they are going to be integrated, you're not 100% sure if they will also function 100% if they are integrated. So the integration of, for example, program 2, program 4, and program 5, so that will be the integration testing. Example, unit program 3 and program 6 is will be tested together. So it is already an integration testing. And then what is the test if you're going to test all the programs all together? So that is what you call the system testing. So you should regard thorough testing as a cost-effective means of providing a quality product. It's not just, oh, programs 1 to 6 is already working individually, so it's just okay, let's already implement it in our organization. No, you still have this integration and system testing. Okay, next, aside from testing, is we also have documentation. So we have 4 types of documentation. We have the program documentation, the system documentation, operations documentation, and user documentation. So for program documentation, what this contains? It describes the inputs, outputs, and processing logic for all program modules. And then for system documentation, describe the system's function and how they are implemented. For operations documentation, contains all the information needed for processing and distributing online and printed output. And then this is the most commonly used for customers. So we have the user documentation, consists of instructions and information to users who will interact with the system and includes user manuals, help screens, and tutorial. This is the most commonly used, the user documentation, because this is the one that is available to the user. We have the user manuals, help screen, and tutorials. So systems analysts usually are responsible for preparing documentation to help users learn the system. So they are the ones who's going to prepare these documentations, the systems analysts. Okay, for user documentation, you can deliver your user documentation online. So effective online documentation is an important productivity tool. So written documentation material is also valuable if the customer prefers the printed user manual rather than the online documentation. Okay, next is we have the management approval. So after system testing is complete, you present the results to management. Of course, the management should know if the system testing is a success or not. If system testing produces no technical, economical, or operational problems, management determines a schedule for system installation and evaluation. So you should have first the management approval before you're going to deploy it in the organization for testing also. Actually, it's not for fully operation. Again, it's for testing. As to why, so let's find out for the next slide. So next is we have system installation and evaluation. So remaining steps in systems implementation is prepare a separate operational and test environment. So it's not yet the final deployment, but you have to test it by using the actual computers or the actual hardware infrastructure available in the organization. And then another is you have to provide training for users, managers, and IT staff. And then also we have to perform data conversion and system changeover, carry out post-implementation evaluation of the system if the installation of the system is a success, and then again present a final report to management. So we have this operational and test environments. If the IT staff is going to test the system in their computer, so that is already the test environment. And then you're going to report to management that there are no problems that is encountered by the system when through system testing. And then you will have the management approval, and then the system will be installed in the actual computers of the user. So that's why it is the operational environment. The test data, procedures, and programs are just the same. The only difference is, of course, the environment as to where the test will be um, implemented. Okay, so the operational environment includes hardware and software configurations and settings, system utilities, telecommunications resources, and any other components that might affect system performance. Okay, let's go back. So, to this illustration. For the IT staff, the test environment, for example, if it is 100% functional, there are no problems. It does not necessarily mean that in the operational environment that will also have a 100% success. It's because the environment that where the test is implemented is different. Maybe, for example, the test environment, the computers that are used here are high-end, while in the operational environment, this is the typical computers that the users are using. So that is why there is no guarantee that if it is working 100% with test environment, that it will also work in the operational environment because of the settings and the actual environment or the hardware infrastructure that is existing in the operational environment. Okay, next is if you have to build or upgrade network resources to support the new system, you must test the platform rigorously before system installation begins. Again, you have to test the platform. Okay, after testing, we also have training. So, it's a very bad practice that if you're going to install the system and then the users will going to use it immediately, unless it is really very familiar with the old system, but it is unlikely to be like that. So, it should have a training plan. So, the three main groups for the training are users, managers, and IT staff. So these are the three main groups. You must determine how the company will provide training. Is it in-house? Is it vendor-based? And then we also have vendor training often gives the best return on your training dollars because of course, if your system is acquired from a vendor, there are the best trainers that you will have because they know the product well. It's not advisable also that one of your staff will going to train unless it is in-house application development. But since it is a vendor, they are the ones who have the best knowledge for training for the system. Okay, and also if you're going to pay most probably the payment for the system, there is already a bundle for vendor training. So let's get this for let's see for the training for users, managers, and IT staff. Let's see are there similar or different training that they will get. So for managers is the project origin, cost benefit analysis, support for business goals, key IT contact people, handling system changes, major reports and displays, requesting enhancements and user training for managers. And then for IT staff is project history and justification, system architecture, system documentation, typical user questions, vendor support, logging and resolving problems, technical training for IT staff, and user and management training. And for the users, systems overview, key terms, startup and shutdown, main menu and submenus, icons and shortcut keys, major system functions, online and external help, frequently asked questions, troubleshooting guide, and handling emergencies. So, as you can see, they have different training sets. For user, these are the operations on how to use the system. while the managers, of course, since they are managers, they oversee the operations of the system, while the IT staff, because they're the ones who's going to develop the system or going to maintain the system. So, of course, they have different training sets for different training groups. Okay, so let's continue with the vendor training. If the system includes the purchase of software or hardware, then vendor supplied training is one of the features you should investigate in the RFPs or requests for proposal and RFQs or requests for quotation that you send to potential vendors. If you're going to acquire hardware or software from a vendor, you have to make sure that there is a training bundled with what you're going to pay, and then often gives the best return on your training dollars because of again the payment that you will be made while acquiring the software or hardware from a vendor. The vendor training is already included in your what you're going to pay. Okay, this can also be done through webinars, podcasts, and tutorials. So for webinars, so what we're doing now, the seminar, so seminars done in the web, and then podcasts are recorded audio that you can listen. These are already recorded. These are not live, so you can download it, and you can listen to it whenever as you please and needed. And of course, the tutorials. So webcast, of course, this is it's like a webinar. Then many people are watching. So example, FB Live. And then it can also be, the training is by means of subscribers. And then as technology continues to advance, other wireless devices such as PDAs and cell phones will be able to receive podcasts. So and then tutorials can be developed by software vendors or by a company's IT team. So again, if the company acquired software or hardware from a vendor, of course, software vendors are the one who's going to provide the tutorials, and then the IT team, if they are the ones who going to they are the ones who develop the system. Okay, another one is outside training resources. So many training consultants, institutes, and firms are available that provide either standardized or customized training packages. Okay. And then what are the training tips? So training tips is you should train people in groups with separate training programs for distinct groups. Of course, as you can see, we have users, managers, and IT staff. So you should separate them. And then, of course, you should train people in groups because it is cost effective than training people individually. And then select the most effective place to conduct the training. Of course, if you need hands-on, so you need a separate computer or a venue with computers. And then provide for learning by hearing, seeing, and doing. And then prepare effective training materials, including interactive tutorials. And then rely on previous trainings. Also, you can ask the opinion of the previous training so that you have additional knowledge. And then we also have interactive training. Usually, a relationship exists between training methods and cost. So, for online training, should include step-by-step instructions, or as much as possible, there is an image so that you will not be understood by the language barrier. And then you could also have video tutorials. You don't have to be a professional video developer to create effective training tutorials. Okay, after the training is we have the data conversion. So we have this data conversion strategies. The old system might be capable of exporting data in an acceptable format for the new system or in a standard format such as ASCII or ODBC. If a standard format is not available, you must develop a program to extract the data and convert it, and then often requires additional data items which might require manual entry. So for data conversion security and controls, you must ensure that all system control measures are in place and operational to protect data from unauthorized access and to help prevent erroneous inputs. So, for example, if you're going to have um, there must be adequate security and control for data conversion. For converting, it should not be corrupted. And then another one, you should have data validation. And of course, for this data conversion, it is inevitable that some errors will really occur. It is essential that the new system be loaded with accurate, error-free data. So next is after data conversion is we have the system changeover. We have four types of system changeover. We have the direct cutover, parallel operation, pilot operation, and phased operation. So for direct cutover, we always from this system changeover, we have the old and new system. For direct cutover, we have the old system, and then for example, yesterday you used the old system, and then on Monday you're already going to use the new system. So that is the direct cutover. And then we have the parallel operation. The old system is still working, and then the new system will be used. And then there is a point in time that they will be used at the same time. And then if it is already okay for the new system to be used, so old system will be stopped. So that's why old system will be stopped in to be stopped in or from usage. So the new system will be the one to be used in the organization. Then we also have the pilot operation. So the pilot operation, the old system is still used, and then there is for example, one office that it will be the pilot site. And if there are no errors occurred or no issues or rather technical issues and concern that will be that is produced while the pilot operation is ongoing, then the old system will be stopped from using, and then the new system will be deployed for, all over in the organization. And then we also have the phase operation. So that this is called a phase operation because you're going to use the old system, and then the new system will be used per function or per module. It's not as direct as the direct cutover. It will be deployed by parts. But there is a separate discussion on the next slide for this system changeover. So, first is we have the direct cutover involves more risk than other changeover methods because if you use the new system, you cannot go back to the old system. So that is the risk. And then companies often choose the direct cutover method for implementing commercial software packages because it is cost effective. And then cyclical information systems usually are converted using the direct cutover method at the beginning of a quarter, calendar year, or fiscal year. So we have this cyclical information system. So they are using direct cutover depending on the period, may it be quarterly or yearly. Okay, next is we have parallel operation. So easier to verify that the new system is working properly under parallel operation than under direct cutover. So because you're using two systems at the same time, you are sure you're closely monitoring if there will be errors or there will be technical issues. So running both systems might place a burden on the operating environment and cause processing delay. Of course, since you're using two systems, you're going to consider the data of the old system and the new system. So there will be, of course, processing delays. So it is not practical if the old and new systems are incompatible technically because parallel operation, its characteristic is that the new and the old and the new system must be at least they are related. They're not really very different systems from one another. And then it is also inappropriate when two systems perform different functions. So parallel operations, less risk but the most expensive. Okay, next is we have the pilot operation. So the group that uses the new system first is called the pilot site. Example, you have this office. They're the ones who's going to use first the new system. And then the old system continues to operate for the entire organization. After the system proves successful at the pilot site, it is implemented in the rest of the organization, usually using the direct cutover method. So because of that, so pilot operation, it is a combination of parallel operation and direct cutover methods. And then last but not the least is we have the phased operation. You give a part of the system to all users. The risk of errors or failures is limited to the implemented module only. It is also less expensive than full parallel operation. It is not possible, this is the disadvantage, however, if the system cannot be separated easily into logical modules or segments. So if it is tightly coupled, you will have a problem with phased operation. So we have this illustration with regarding to the cost and risks of this system changeover. So for direct cutover, so it from the four compared to the other system changeover techniques, direct cutover has the lowest cost, but it has the highest risk. Because if there is, again, if there is an error in the new system, you cannot revert back to the old system. Okay, next is we have pilot operation and phased operation. These are, for the cost, it is medium, barely below medium. And it also has, with regards to risk, these are the safest, the pilot operation and the phased operation. And then parallel operation is, the cost is high, but the risk, this has the lowest risk factor. So, what are you going to use? So, it depends upon the context or situation that your organization has. But in more commonly, it is better since this is the middle, the pilot operation and the phased operation for system change over. Okay, next is we have the post-implementation tasks. So we have the post-implementation evaluation. So it should examine all aspects of the development effort and the end product, the developed information system. You can apply the same fact-finding techniques in a post-implementation evaluation that you used to determine the system requirements during the systems analysis phase. So you can use interview, observation, or documentation, and the like. And then, of course, since you have this evaluation, you have to report it to the management, the final report. So your report should include the following: final versions of all system documentation, planned modifications and enhancements to the system that had been identified while it is being tested and used by the end users, and then recap of all systems development costs and schedules. So also, there is also a comparison of actual costs and schedules to the original estimate. So does the information system, does it cost more than the previous estimated cost? And then also the schedule, did the project finish on time? And then, of course, you have to present the post-implementation evaluation if it has been performed. And then this marks the end of the systems development work. So for chapter summary, so the systems implementation phase consists of application development, testing, installation, and evaluation of the new system. Analysts and technical writers also prepare operations documentation and user documentation, and then develop a training program. A post-implementation evaluation assesses and reports on the quality of the new system and the work done by the project team. The final report to management includes the final system documentation, describes any future system enhancements that already have been identified, and details of the project costs. And then the report represents the end of the development effort and the beginning of the new system's operational life. So we're already finished with chapter 11. So I hope you learned something from this lesson. So if you do have any questions, any comments, and suggestions, so feel free to comment below. And please don't forget to like my YouTube channel. So again, thank you very much and good day to all of you.